Greenhouse gas emissions contribute to global warming. The impact of drastic climate change has become the most important issue of this century. Therefore, carbon reduction and energy issues have become the consensus of the whole people. Carbon capture and storage (CCS) for short refers to the technology of collecting and storing carbon dioxide. The aim is to actively reduce the concentration of COR in the atmosphere. Electrochemical carbon dioxide conversion technology is currently the new favorite to solve this problem. Not only create new economic drivers, at the same time, it also provides humans with cleaner and sustainable alternative energy sources. Based on this idea, the research team, working on a breathable fuel cell that captures carbon dioxide from the air. Even though the target gas makes up only a tiny fraction of the atmosphere, still useful. This innovative metal carbon dioxide fuel cell breathes air, a chemical that absorbs COR and converts it into electricity and renewable energy at the same time. Not only to achieve the purpose of capturing COR, it can also be stored and reused. Reduce reliance on traditional fossil fuels towards a more economical and environmentally friendly direction. It is a low-cost, high-efficiency optimal CCS technical solution. Metal carbon dioxide fuel cell in operation. Mainly through the redox reaction of active metals and carbon dioxide to generate electricity. Taking magnesium COR battery as an example. The basic structure of the battery is the anode, cathode and intermediate electrolyte. During discharge, the anode magnesium metal oxidizes and releases electrons. When this electron travels through the circuit to the cathode, porous carbon electrode will form oxalate ions with oxygen, water and carbon dioxide. Carbon itself does not participate in the reaction but only provides an active site for the reaction, so no loss. Oxalate ions will finally pass through the intermediate electrolyte and combine with metal magnesium ions to form magnesium oxalate. The overall reaction is like a clean energy storage device that captures and converts COR into electricity. Metal carbon dioxide battery is very important in the selectivity of raw materials. Not only depends on the carbon dioxide capture capacity, the power density of the generated electric energy also depends on battery preparation and operating costs. Cathode gas diffusion electrode. It is often necessary to add noble metal catalysts such as platinum and palladium to improve battery performance. But these catalysts are usually expensive, is to lead to the metal carbon dioxide battery. The main reason why it is difficult to compete with other types of batteries. Therefore, the research team proposed the most innovative technology research and development for this bottleneck. We selected native tree species from Taiwan. The fruit of Formazan sweet gum as a natural bio-based carbon material. Because the sweet gum tree is a sun-loving tree species, it is widely planted in parks, green spaces, streets and schools in Taiwan. Its spherical capsules fall naturally in autumn and winter. So easy to get. Natural maple fruit activated carbon prepared by hydrothermal method. Doped nanometallic copper as gas diffusion electrode not only can effectively improve the discharge capacity density of fuel cells, it also greatly increases the absorption capacity of carbon dioxide. This enables the battery to capture carbon dioxide and generate electricity in a low concentration atmospheric environment. After a lot of research time invested by the research team, active carbon gas diffusion electrode of maple fruit can be produced in the laboratory with standardized methods. Production technology is quite cost-effective, estimated to be 1/10 the cost of commercial porous carbon gas electrodes. And the ability of the battery to capture carbon dioxide, it is also far more than twice the commercial standard value stipulated by the U.S. Department of Energy. Humanity's reliance on fossil fuels grows. More carbon dioxide is released into the atmosphere. This greenhouse gas contributes to global warming and dramatic climate change. Is an urgent issue. Multiple studies point to it is not enough to only passively reduce COR emissions. More aggressive capture of carbon dioxide already in the atmosphere is required. In order to effectively slow down the rise of the Earth's temperature, the magnesium carbon dioxide battery developed by this research team, potential to capture COR, generate electricity and store energy into one integrated system, we expect to be integrated into the flue of large factories in the future. Significantly reduce the concentration of carbon dioxide in the exhaust gas. In the process of purifying exhaust gas, carbon dioxide will be concentrated and accumulated, converted to oxalate for storage during current carrying discharge. Let the magnesium carbon dioxide battery play the role of a cleaning machine. Give full play to the best benefits of power generation and energy storage, towards a more economical, environmentally friendly and sustainable direction.